This video is on inverse functions algebraically. I'm going to be doing the last example, which is different than what we've seen because on all the other ones we've had a quadratic or a square root or a cubic. This is a rational function, meaning that we have x's on top and x's on the bottom. Means we cannot divide by 0. So we have to be careful about our domain and our range because we will have asymptotes. Now, a basic sketch of a rational function would look something like this. It would have an asymptote for the y value, but it would go off to the right forever, potentially. But then it would also have a asymptote at somewhere for the x as well. So this is a general sketch of what this could look like. The thing is that this is not going to be 100% accurate to this. I was just drawing a basic sketch of this. So what I actually want to do is graph this in my calculator to see which direction it's going in. So I'm going to turn my calculator on. I'm going to go to my y equals, and I'm going to graph this. So my numerator has multiple things in it, so I'm going to put parentheses around that. So parentheses, 2x minus 1, close parentheses, divided by, and the denominator also has multiple things, so I'm going to put parentheses around that, x plus 3, close parentheses. Now I'm going to press graph. So my sketch is actually backwards from what this is. I have it going down and to the right, but this one's actually going up and to the right. So my sketch is backwards, but I still have an asymptote here. This line will not be crossed. Now, we also have an asymptote going vertically here because it will not cross that value. We can actually find that value by looking at the equation and also looking at the graph. Now, the domain is finding that which x value is not crossed. That looks to be about a -3. So if I go to the table, so if I go to second graph, and I go to a -3 on the x, we actually have an error because it's not hit there. So that is the asymptote. That will help us with our domain. So if I go back to the graph, I still want to see if this original one is a function. It will pass the vertical line test because this does not go vertically. It does keep going to the left, but very, very, very slowly, and it will never cross that -3. So this one is a function. Our domain is slightly different though. On this graph, it will go forever to the left, so we will have a negative infinity, and it will go forever to the right, so we will have a positive infinity. But there is a break in here because it cannot cross that -3. That -3 has an error on it. That means that it will not touch that -3. So that's where it stops, but then it starts back up. So we want all of the x values from that negative infinity up to that 3, but we cannot, or that -3. But we cannot actually touch the -3, so I'm going to have an open bracket. But then we want every single number after the -3, just not including the -3. So we're going to unite them with the union. We have to start it back up at that -3, but it just can't include it. So every x value except the -3 is being used. It's going to go to that positive infinity. Now, by looking at the equation, we can actually determine what that would be by looking at the denominator. The denominator gives you your h value. So our x minus h over here, this would be x minus a -3 because we cannot divide by 0. -3 will create this to be a 0, and we cannot divide by 0. That's why there's an asymptote there. For our range, looking back at our graph, our graph does go down forever, and it will also go up forever. So we will have a negative infinity and a positive infinity. But again, there's a gap. There's a gap between these y values. These y values, we need to figure out which y values are never touched. So it's around maybe a +2 or a +3. So if we go to our table, we want to look to see, so as the x's go towards the positive, so we're going to go positive x values. Let's see where that y value goes towards. So I'm going to scroll down. So thought maybe it might have been a positive 2 or positive 3. So if I keep going down in so my x values keep getting bigger, it looks like it's going to keep approaching that positive 2, but probably not going to get to it. So yeah, it doesn't look like it's going to hit that positive 2. So if I go back to the graph, I want to check the negative x's as well. So again, that positive 2 or that positive 3. So I'm going to go back to my table. I'm going to go towards that negative x value. So I'm going to scroll all the way back up on my x's. So go to those negative x values. We know it's going to be after that negative 3 because that was the error. So now watching these, let's see if it crosses the positive 3. It looks like it will cross that positive 3, so that's not the asymptote. And it looks like it's going to keep getting closer and closer to that positive 2. So it looks like it's not going to actually get to the positive 2. So our range will include that it's going to go from negative infinity up to that positive 2, but just not include it. But then it's going to start back up. Again, we want all the y values except for that positive 2. So go from positive 2 to positive infinity. Now, the way you can actually determine your range is by looking at your coefficients. Because these these variables have the same exponent, you can divide the coefficients to determine your range. So 2 divided by 1 is 2. You will see this again in another time. So we do have our information for the original. That means we can find the inverse information. This will pass the horizontal line test as well because it will keep going, but it just gets really, really small. Just never touch that value. So the inverse will also be a function. The domain will be that negative infinity to the positive 2, open bracket, union, that positive 2 to positive infinity. The range will be that negative infinity to the negative 3 with an open bracket, union, we're going to start back at that negative 3 and go to positive infinity. So now let's find the actual equation of our inverse. This is the most difficult kind. It will have quite a few steps. We're still going to change the f of x to y. We're still going to start everything else the same. It's that solving for y where it gets a little tricky. We're going to have x is equal to 2y minus 1 over y plus 3. So follow along with these steps. We need to get the denominator off so we can have one nice equation. So we're actually going to multiply both sides by the y plus 3. So I'm just going to take this y plus 3 and multiply it over here. So I'm going to keep the x times y plus 3 is now equal to 2y minus 1. Because the y plus 3 got away from the denominator and went over onto this side. Now I'm going to distribute this x for a reason. So we're going to have x times y plus 3 times x is equal to 2y minus 1. Now we have two different y's on here still. We actually need to get the y's together so that we have all the y's on one side and everything else on the others. So I want to keep this xy over here, but I want to take this 2y and subtract it to this side with it. I'm going to have that minus 2y. Now I actually want to get rid of this 3x because I don't want it on the same side with the y's because it does not have a y with it. So I'm going to subtract this 3x to the other side. So we'll have equals a negative 3x. We're going to keep this negative 1 on the right-hand side. Now that we have all the y's on the same side, they both have a y with it. We can factor out a y from both of those. We'll have a y on the outside, and then we'll be left with an x minus 2. Because again, if I distributed this back, I would come back to this. Is equal to negative 3x minus 1. The reason we did this is because now we actually only have one letter y. So we can just get this y by itself by dividing by this entire set of parentheses. So we'll end up having that y is equal to, this will be our numerator, the negative 3x minus 1, divided by, then we're going to divide by this entire parenthesis set of that x minus 2. we actually have our inverse. So coming back to this information over here, we can again find our domain and range. The domain will be from the denominator. What will make this 0 is a positive 2, and we can't have that. So that's why that domain, we go to the positive 2, but we cannot include it. The range will be from if we have the same exponent on here, so these are the same, x and x, we can divide the negative 3 and that positive 1, which is what gave us that negative 3. So we have our inverse. This will be f inverse of x is equal to a negative 3x minus 1 divided by the x minus 2. This one, you have to remember to distribute whatever you multiplied to right here. When we got it off the denominator, you needed to actually distribute that so that you could be able to get all of your y's back together. Other times, when we're dealing with quadratics like this, we actually don't want to, when we're dealing with like square roots, we're getting the square roots, you don't actually want to distribute that. You don't want to distribute the y minus 2 squared again. So you want to be careful when you have this. You don't actually rewrite it twice and make it into standard form because you want to have it in your h and k values. This one, in order for us to be able to even get our y's together, we had to distribute them to get rid of those parentheses because we needed to get all of our y's together. This is a rational function, so this is why it's a little trickier, and you will see this in another unit. This actually goes on further into the course.